Alright, so here we're going to start looking at using LiDAR data in ArcGIS Pro. So we're going to start off with some raw point data and then work our way up to generating some output, for example, DEMs, NDSMs, so on and so forth. Okay, so I've already obtained some data. There's different places you can go to get LiDAR data. I'm just going to show you a few examples. So one option in West Virginia is the West Virginia Elevation LiDAR download tool. So if you do a Google search for that, you should find it. So it's just the View Elevation and LiDAR download tool. That's where I got the example data from. So this shows the extent of available data in West Virginia, and you can download, tiles and whatnot. Another good source is the 3DEP program in the U.S. The U.S. is currently working towards generating a high resolution LiDAR, or mainly LiDAR derived data set for the entire country, so you can look there for data, and lots of other states have portals and whatnot. Okay, so first thing we want to do is bring in some data. I'll show. So I have some data in a folder, and they're in LAS format, but unfortunately those data types can't be read into Arc directly. Instead, you have to first create a LAS dataset. So let's do that first. So we'll do LAS Dataset. Oh, I'm in the wrong window. I'm going to go to Geoprocessing, and we want to do LAS Dataset. And we want to do Create LAS Dataset. Okay, so we want to grab some files to throw in here. So I'm going to go to this folder where I have some data stored. So let's see, where are we here? LiDAR, and here's some LiDAR. These are in ZLAS format, which is like a compressed file format, but Arc can read those. So anyway, that's 6 files, so I'm going to grab those. And hopefully it should find the projection. Looks like it did there. Sometimes if it doesn't, it won't, if it can't read the file correctly. All right, and then we got our coordinate system. We'll have a compute statistics, and let's just change the name. So I'm just going to put it in the same folder, and we'll call it example LAS DS. Okay, and then that should work. So let's just run that. Okay. All right, so this is for the area around Romney in West Virginia, as you can see here. By default, it just shows you the extent, and here we have 6 tiles that are adjacent, so those are just the extents. And then to actually see each individual point, you got to zoom in a little bit, and then you can see all the individual point measurements in the point cloud. As you can see, there's a good bit of measurements there. Okay, so to actually look at this against some imagery, let's read in some imagery. So I'm going to do new ArcGIS server connection, and I'm going to connect to West Virginia GIS Tech Center Data Services, and I'm just going to connect to this service, and we'll dump it in there. And then this should read in some fairly high-res data, or image data we can have to view our data against here. Sometimes these images take a little bit of time to load in, so just have to give it a minute. So while it's working, you can see here that we've got a pretty dense data set. Each one of these points represents a return from an XYZ coordinate measurement in the space. So this allows us to create a lot of different types of products, so things like DEMs, DSMs, NDSMs, intensity images, 3D models, terrain derivatives, visualizations. So there's a lot we can do with that. Oh, actually, I guess I didn't actually bring that in. Let me try again. Realized I didn't actually go in and grab the service. I just did the connection. So grab that there. So that'll actually read in the data. Okay, there we go. All right, so I thought that would be good to have just for visualization purposes. And I'm going to move it down so our LiDAR is above it. So note that a LAS dataset is kind of like a mosaic dataset. It's not a file. It's basically just a reference to a bunch of files that allow us to use them more efficiently. So again, if we zoom in here, we can see the density of this just against like roads and houses. So it's a pretty good data set, as you can see. All right, so let's actually do some changes to this in terms of how we're visualizing it. So first thing I want to do is add a filter. So when you have a LAS data set, you should be able to filter the data. So there should be this option under properties called LAS filters. This is just some like standard ones. If you want to have more options, if you go into Symbology, I believe. Let me see here. Where is that? There should be an option for that. Maybe it's under properties. Okay, there we go. So you go to LAS filters, then there's a bunch more options here. So let's say we just wanted to see the ground returns. So to do that, we could turn off this, just do ground, and yeah, so anything that's ground, this should return. So do that. So now if you zoom in here, you can see that the points that were above, above ground features like buildings, those have been removed from the data set. So we basically just have our ground returns. So that's an example filter. And then just to go back in here again, if we go to our properties and filters, we could just do, for example, other classes. The only thing this data set has is ground, unassigned, and like outliers. So there's really not much else we can do with that. If you do last, that'll be the last return if there's multiple returns from a single pulse. First to many is the first return if there's multiple returns. Last to many is last, but only if there's multiple. If you just do last, it'll include things that are just the last return, but not necessarily the ground. Single returns, and you can do by return number. And then there's some other things such as synthetic points, key points, overlapped areas. So there's lots of options there. Note that when you set a filter, that will be honored in the tools that you run after the fact. Okay, so that's filtering. Let's just go back to everything for now. Now, you can change the visualization. To do that, you go into Symbology, and then there's a couple different options here. So right now, we have them symbolized in a color ramp based on elevation, but you can see there's a bunch of other options here. So you have scan angle, classification, return number, number returns, intensity, all kinds of things. So, for example, if we did intensity, that's the return intensity, which we'll look at as a raster later. Classification, basically we only have a few that are actually being used in this case. One is unassigned. We have some noise ones, and then we have ground, right? So ensure there's different ways to symbolize the points. You can draw contours. That may be slow. Oh, I think we need to switch back to elevation if we want to do that. So, and if we turn this off, there we go. Now, that's still, basically because we're not looking at the ground. Let's do a filter on that for real quick. So we'll go back in here, properties, and we'll just change this to just ground. And then we get a kind of rough estimate of ground elevation contours. This kind of just deriving on the fly, just for visualization purposes. Okay, so that's that. I'm going to turn that off now. This is edges. Let's see what that does. I actually don't ever use this. Okay, so that basically makes like a triangular facet surface out of it. kind of like a 10, but all you're really seeing, you're just seeing the edges. You're not seeing the actual 10 surface. Turn that off, and then we have a surface, and we'll just do it by elevation. Zoom out here. There we go. So now we're seeing it more as like a continuous surface. And then again, we just filtered out by ground, so we're really just seeing the ground measurements. Okay, so these are just some different symbology options, and obviously you have options in here to change classification methods and all kinds of stuff, right? So I'm just going to turn the points back on. Okay, so now let's say that let's say we want to actually produce something from this, like some derivatives. So let's look at how we can like rasterize this data and create different surfaces from it.